Good afternoon, everybody, and thank you for dialing in to today's virtual masterclass, a non-promotional webinar organised and funded by AstraZeneca and MSD. And today we're going to be talking about lessons learned from the 2022 worldwide EQA schemes for molecular testing of BRCA and other HRR gene variants in ovarian and prostate cancer. Next slide, please. So I've got the dubious duty of presenting all the housekeeping slides, and the first slides up front. So we've automatically muted your microphones to avoid any background noise. Please try to ensure that you keep your microphone switched off. We are recording this webinar, and we should be able to make it available to all of you to watch offline within the next 2 to 3 weeks. So that's great. So you'll be able to share that with your colleagues, etc. Most importantly, we do really appreciate your feedback in terms of feeding back to us about or your questions, for example. So there is a Q&A function, which on the bottom of your Zoom screen, which you can use to submit your questions to Sandi and myself. And we'll try to cover as much as possible. It's going to be a bit tight today because we only have 60 minutes or so, but we've probably got time for several questions anyway. And anything that we don't answer directly in the webinar, we'll pick up for you afterwards. So we'll reply to you afterwards. So just do, if you want to reply, please do make sure you leave contact details, but otherwise we'll pick it up afterwards. Okay, next slide, please. So your feedback is really important for us. So we always listen to what you say. Hopefully by doing so, we've over the years really improved the quality of what we're providing to you, these virtual masterclasses. Please do continue to provide feedback to us. So you will receive an email after the masterclass with a short link to our feedback survey. Shouldn't take more than 2 or 3 minutes to complete. And as I say, it really helps us to understand what your needs are and how we can improve our activities in future years. Okay, next slide, please. So I'm going to hand over to my co-chair, Sandi, and we'll progress with the webinar.
Lovely, thank you, Simon. So just to add my welcome to Simon's, and we will kick off the webinar now. So I'm Professor Sandi Deans. I'm Director of GenQA, one of the EQA providers, and you've just heard from my colleague, Dr. Simon Patton, who is the Managing Director of EMQN as well. So between the two EQA providers, we have given this EQA assessment to as many participants as we could over 2022, and this is really building on previous years of assessments. So next slide, please. Quick disclaimer just to say that it's funded by AZ and MSD. It's non-promotional webinar, and the views are of Simon and myself, so nothing to do with the sponsors, and we have received honour area. Lovely. So moving on to the overview. So as I've just explained, this is a collaboration between 2 global EQA providers in the field of genomics. We're now offering 3 EQAs in this scope, and it's the 7th EQA run for the germline and the somatic BRCA testing in ovarian cancer. And really, we've sort of extended these now to include other HRR genes. We've also going to discuss today the new pilot scheme that was launched last year for the cell-free DNA testing in prostate cancer. So the format of all of these EQAs is that we provide 3 samples, each per sub-scheme, and these are distributed with corresponding clinical cases. And the idea is participants test them and report using the routine protocol. So we really want to assess what's happening day to day in the laboratory and not asking labs to deviate from normal processes. The schemes have grown, as you'll see with some of the data that we're going to present today, and we now have a team of 40 assessors from 14 countries, and I think that just reflects the outreach that these schemes have. And what's really important is, despite which EQA provider that the labs sign up to, we run harmonised marking and assessment, so we work across the same marking criteria regardless of which country each laboratory comes from. So next slide, please. So the main principles of EQA is that we provide the same starting material, so the same testing material to all laboratories, and that really makes sure that we can then benchmark and can accurately make comparisons across the scheme results. And I think that's really important, so no bias between different methodologies or testing approaches, and that's really important for EQA impartiality. So the results, as in the routine report, is returned to each scheme and were assessed anonymously by a panel of expert advisors who I've just talked about. So it's really important that they are tested and processed in exactly the same manner by the people who do this testing day to day. And then we assess the EQA results to determine the accuracy of the laboratory. So it's that external measure of the standard of service. So the advantages are, as well as that quality metric measurement, it provides continuous education and training, and often we pick up areas where reports or testing strategies could be improved, or also identify unmet training needs. The other element of EQA is about performance monitoring, and EQA performance, because it is that benchmarking exercise and it is externally delivered, then other key stakeholders use that information for their decisions whether to use the service or not, such as regulators, commissioners, service users, clinical trials, other areas of activity whereby they would use the service of the laboratory. So it's very important on multiple levels. So let's kick off with some of the real data and hear the outcomes of the 3 EQAs. So I'm going to hand back to Simon, and he's going to tell us about the germline scheme. Simon?
Thanks, Sandi. So, so today's slides are in the normal order that we run them. So we're doing germline, somatic, and then we're going to be talking about the new pilot EQA scheme at the end of it. So next slide, please, Sandi. So quick overview of the demographics of participation from this year's scheme. So we've got all the data here since 2016, and what's important to say is that probably about 3/4 of the participant laboratories are routine participants that are coming back year after year into the EQA scheme, and the remaining 25%, as you can see in the different shades between purple and blue, are laboratories that are new to the EQA scheme or new to the EQA process. And when you look at the demographics split it out by region, you can see that about 50% of the participants in the scheme come from Europe, another 21% of them come from China, and then we're split across the other global regions, so Oceania, Asia Pacific area, Africa, and North and South America. Next slide, please. For this scheme, we distributed 3 genomic DNA samples. So that was DNA extracted from lymphoblastoid cell lines that EMQN holds in Manchester. They were selected for specific variants where we know the results, so we can measure against expectations. And every one of the samples was independently validated using NGS by 2 separate laboratories, including the use of CNV analysis prior to the distribution to laboratories. So we had 2 laboratories, one used an Illumina NextSeq 500 strategy with 115 cancer genes from Agilent, and then confirmatory testing was done by Sanger sequencing. And then the other laboratory was doing the test, an NGS test on the MySeq platform, 38 genes this time, using a Sophia Genetics custom hereditary cancer solution. That included CNV analysis, and then they also confirmed variants using Sanger sequencing. So we've got plenty of confirmatory testing there to back up any pathogenic variants that we've identified. Next slide, please. So looking at case 1, so case 1 was a lady called Josephine Wassu, and Josephine had been diagnosed with ER positive HER2 negative breast cancer, which had metastasized to her bones. And she was being considered for PARP inhibitor therapy, and so testing was being requested to see whether that was an applicable treatment for her. So the rationale for this case is it's a breast cancer case and progression and first-line treatment with PARP inhibitors. And the question we're clearly asking in all these cases is a pathogenic variant present in the germline. Next slide, please. So for this case, there were no pathogenic variants detected in either BRCA1 or BRCA2. But there was a polymorphic stop variant detected in BRCA2, so that was noted, and you'll see from the genotyping data that had a significant bearing on the results. The other thing I want to highlight here is that both organisations have moved to using the main select transcripts rather than recommending LRGs. So if you weren't aware, that LRGs have now been discontinued and are no longer supported, so we're moving towards using reference sequences defined by the main the main project. So for reference for laboratories, this year we've been reasonably generous on highlighting that, but in future years we'll be picking up a bit more on making sure that laboratories are complying with making the right transcript and the transcript version moving forward. So looking at the genotyping, there was one critical genotyping error, so 0.4% of the laboratories this year, and that was a false positive result. So the laboratory detected a variant in BRCA1. Next slide, please. Looking at the interpretation of the results, so there were 2 critical interpretation errors this year. So just a reminder, any critical error is an error that can cause potential patient harm and therefore is deemed to be of critical importance and is classified as a poor performance as a consequence. So looking at the interpretation, there were 2 errors this year. So one laboratory reported the benign polymorphic stop variant as pathogenic, whilst the other reported the correct genotype, but included a statement in their report that the sample was positive for a clinically significant mutation. So again, the wrong interpretation, even though they got the correct genotype in this case. Some laboratories classified the polymorphic stop variant as a variant of uncertain significance. And in those cases, laboratories received a small deduction, a half-a-mark deduction for incorrect classification. And there's certainly, at the moment, there's not good evidence to recommend BRCA1 and BRCA2 testing, or even more further, HRD testing in the context of breast cancer. So yes, certainly in ovarian cancer, but not in breast cancer at the moment. So again, that was another one of the findings we picked up from the assessment process, as a recommendation for wider testing in those contexts. Next slide, please. So on to case 2. And case 2 was a male called Vikram Chowdhury, and he had a castration-resistant metastatic prostate cancer and was receiving hormone therapy. And he's been considered for PARP inhibitor therapy. So again, the rationale of this case is a prostate cancer case, first-line hormone therapy and subsequent progression, and is a pathogenic variant present in the germline. Next slide, please. So in case 2, there was a pathogenic variant in BRCA1, so a heterozygous mutation, 62 base pairs in size, and no pathogenic variant detected in BRCA2. And there were 6 critical genotyping errors in this case, so 2.3% of all the samples tested in this case. There were 4 false negative results where the laboratory failed to pick up the pathogenic variant in BRCA1. And there were further 2 false positive results where the laboratory incorrectly reported a BRCA variant. So both of them were BRCA1 variants, and both of them were deletions as well, but not of the right size. So this deletion in this case was quite a complex test. So we deliberately included a deletion of a size length that can be quite challenging for some of the methodologies laboratory use. So we have a number of different variants available to us in this sort of classification, if you like. Some sort of 40 base pairs, some a few larger, and this one 62 base pairs, all of which we know are challenging for laboratories. So we not infrequently will make sure that we cover this type of test in our EQA scenario. So in this case, it was the 62 base pair deletion that would cause quite a lot of challenge for some laboratories. So next slide, please. So there were lots of problems associated with detection. So there were quite a few laboratories that didn't detect the deletion. So they weren't given a critical error because their methodology was unable to detect it, and they clearly stated that in their limitations. So these laboratories have confirmed that they can't detect it, this type of variant, and clearly stated that in their reports, which is good to see. There were some laboratories that reported a partial deletion when using MLPA. And so although their results were correct within the limitations of MLPA, they should have further characterized the deletion or advised as such in their interpretation. So those laboratories did actually receive a small deduction as a consequence. There were some laboratories that reported the deletion of the whole exon, and were given a deduction for an error in this case. And there was one laboratory that reported only part of the deletion, and they were also given a 0.5 deduction. So again, two variations of the same thing, one too much of it, too big a deletion, the other one too small a deletion. And some laboratories reported the correct deletion for the cDNA change, but incorrectly reported it for the predicted protein change. So significant variation in how laboratories handled this case. which was part of the reasons for including it, to challenge laboratories in unusual cases where they've got these samples of these variants of challenging perspective for the test process. Next slide, please. Looking at the interpretation, that was much better than in case 1. So there were no critical interpretation errors this year, which is good to see. The common reasons for deduction were, and we see this reasonably frequently, and we'll come to it later on in the presentation, not advising genetic counselling or follow-up for the patient, and also failure to provide a version number for the MLPA kits. We've discussed the MLPA side of things. It's really important to make sure you include the version number there. Kits differ in terms of what the scope of the test is, so you must include the actual version of the kit used as well. And not advising genetic counselling or follow-up is considered a mandatory requirement in these cases, and so because there may be implications for the family as a consequence of finding the variant, and the laboratories in both cases lost marks. Some laboratories didn't fully characterise this deletion and provided an interpretation that could not be confirmed without characterising the deletion further. So we did provide a comment to that, but they didn't lose any marks. And this is particularly important if the MLPA shows a copy number change. You must always try and verify the outcome of the MLPA test to make sure that it's not due to something that could be affecting the probe binding process of the MLPA primers. Some laboratories reported a variant allele frequency below 50% and provided misleading interpretation of that lower variant allele frequency. So effectively, we're maybe saying that it was perhaps more due a somatic variant as a consequence because it wasn't present at 50%. It's important to note that this low VAF is an artifact of bioinformatics alignment, and therefore you should really be very cautious with how you interpret low VAFs in this context. Next slide, please. Final 2 points to sort of highlight on the interpretation of this case. The report should clearly state if the sample was tested for LGRs, large genomic rearrangements. Some laboratories are not including that, and we've repeatedly emphasised in previous years that you must make sure you state the scope of your test and the limitations of the test. And some laboratories discussed ovarian cancer risk for this patient, which of course wasn't appropriate within the context of the case. This was a referral for a prostate cancer sample, not for ovarian cancer. Next slide, please. So case 3 was a lady called Pamela Ianardis, and she'd been diagnosed with serous ovarian cancer, and her tumour was shown to be platinum sensitive. Testing was requested to determine further treatment options, including the use of PARP inhibitor therapy. So the rationale for this case, this is the ovarian cancer case, maintenance therapy after response to a first-line treatment with platinum, i.e. the patient's not relapsed. And again, is a pathogenic variant present in the germline of the patient. Next slide, please. So for case 3, we were expecting laboratories to find a heterozygous pathogenic variant in BRCA2 and no pathogenic variant in BRCA1. And looking at the genotyping, there were 3 critical genotyping errors, so 1.1% of the cases tested. All were false negative results, so failure to report the variant of the pathogenic variant that was present in BRCA2. There were some errors in HGVS nomenclature reported for this variant, primarily because laboratories aren't assigning the position of the deleted variant position at the 3' end and using the 5' end instead. So please make sure that you pick up on that. It's very, very important from an HGVS perspective to make sure you assign it from the 3' most possible end. And also a common theme across not just this scheme, but actually across many of the schemes, is that according to HGVS nomenclature, the latest version, which is version 20.05, it's not necessary to indicate the nucleotides that have been deleted. So only the cDNA coordinates for the nucleotides that are deleted are required. So you don't need to say which bases have been deleted in your interpretation of the variant. Next slide, please. In the interpretation is a much more straightforward case. There were no critical errors this year. And the common reasons for deductions were similar to case 2. So in fact, exactly the same as case 2. So not advising genetic counselling or follow-up for the patient, and failure to provide version numbers for the MLPA kits. And as in case 2, laboratories lost marks if they didn't include those statements. Okay, next slide, please. So looking at the scoring for these cases this year, and the scores reflect obviously the complexities of the different case. So case 2 had consistently lower scores for both the genotyping and the interpretation, shown by the blue and purple bars. Case 1 was the no variant present in BRCA1 or BRCA2, so you can see that was done very well by most laboratories. And as always the case, the interpretation scores are always lower than the genotyping because it's much more subjective, the assessment of interpretation and the complexities around how you word these scenarios. But good to see the clerical accuracy and reporting standards are really high, as they usually are in all of our schemes. So, you know, the way laboratories impart that information back to the end user is still pretty good, which is good to see. Next slide, please. So looking at performance trends, so we've presented the data here so as a percentage of participation. So you can see that about 11% of laboratories in 2022 didn't report results back to EMQN. So that's 89% of laboratories did provide results for assessment. A small number of laboratories, about 2%, we actually withdrew and let the EQA providers know why they were withdrawing. But the other 8 or 9% of laboratories didn't submit results and didn't give the EQA providers a rationale or reason for why they weren't submitting results. These laboratories do get poor performance. So if you are one of those labs that doesn't tell the provider why you're not submitting results, you need to be aware that you will get poor performance if you do that. And it's pertinent to make sure you let us know before the results submission deadline as to why you're withdrawing and not submitting results. So looking at assessment scores, you can see that they, as expected, fluctuate between years. Genotyping is always more consistent and higher than interpretation, but the fluctuations because we're mixing up different clinical scenarios and challenges each year. So we're not expecting to see equal marks across every year. We're expecting to see variation in the scoring each year based on the challenges we provide. Looking at the critical error rates, the great thing here to see is that the critical error rate is coming down. Again, as we would expect from a mature EQA scheme when many laboratories are taking part, and as we showed in the first slide, 75% of laboratories have participated at least once. So the learning from that process is clearly kicking in and the error rates are dropping down significantly, which is great to see. And also that's reflected in the number of poor performing laboratories. So you can see this year is only 3% of laboratories were poor performers, significantly down from over 10% last year. Again, great to see. So good improvement. So well done to all the laboratories this year for really delivering some good performances this year. Okay, next slide, please. So I'm going to hand over to Sandi for the somatic cases.
Thanks, Simon. So this is for ovarian and prostate cancer. So if we go to the next slide, please. Again, just to mimic what we showed for the germline scheme, this is the demographics for the somatic. You can see there's a steady increase in participation over the years. And just like previous years for 2022, there was many of the participants were returning participants, which is good to see. Again, similar picture to germline as to the location of the participants. About half of our labs were based in Europe, and then about 16% both from China or Asia Pacific regions. So next slide, please. So I think we all know that the somatic testing is particularly challenging, and it's not just as challenging for the laboratories, but also it's quite challenging for EQA providers to be able to facilitate such an assessment. So we need to make sure that we reflect the tissue samples that are tested within the laboratory, but obviously we can't use true patient material just because of the limitations of the amount of material, and the fact it's very important to be able to provide the same testing material to all participants so we can provide that benchmarking and performance monitoring. So that's something that we have to tackle, and we do use cell lines embedded into FFP material to try and mimic that true patient sample. We also have a range of laboratories, as you see, not just across different countries and continents, but also there's different national approaches to testing. We know that some countries or some regions do tumour testing first and some do germline testing first. So we need to make sure that we cover and assess any format that is taken. So we have two expectations. One, we expect both BRCA1 and BRCA2 to be tested and reported, and we split the germline and somatic EQA assessments out, just as Simon has just covered the germline, and the somatic is a standalone as well. We also select samples, so there's a different types of variants and different classifications, and we provide expert review, so we know what the classification evidence should be if there's ever an issue with pathogenicity or not in reports. And then also we want to make sure that the laboratories participating in the somatic scheme understand the importance of potential germline variants, and I'll talk about that in a bit more detail shortly. So next slide, please. Excuse me. So as I mentioned, we send out 3 different samples for each EQA run, and these are based on cell lines who are manufactured to a bespoke specification for us into formalin fixed paraffin embedded samples. We select the cell lines specifically for variants or challenges we want to provide to the laboratories, and then just like the germline scheme, we make sure that these are validated independently by laboratories by next generation sequence prior to distribution. So we're very confident on what is present in the sample prior to the EQA run. So next slide, please. So the first case, Miriam Dawood, was a female who has platinum sensitive serous ovarian cancer. So she's had surgery, received a round of platinum based chemotherapy, and is now being considered for maintenance therapy with PARP inhibitors. So the same question as the germline scheme, is there a pathogenic variant present, but is it present in the tumour, because this is a tumour sample EQA that is being tested. So next slide, please. So this case had a BRCA1 pathogenic variant detected and no pathogenic variants in BRCA2. We, however, had quite a high critical genotyping error rate, so 22 laboratories reported the incorrect genotype. So we had 13 who reported a false negative result, so they did not detect the BRCA1 variant. And we also had 9 further laboratories with critical errors whereby they incorrectly reported a different variant, and that was across both of the genes BRCA1 and BRCA2. So here you can see there's no trend, that there's no common variants that are being detected potentially at low level, because we know that the sample is homogeneous due to the nature of manufacture. But so these are real true incorrect genotyping errors. So next slide, please. Also, we had some laboratories that didn't characterize the deletion and reported it as a general statement that a large deletion was detected. And it was felt very much by the expert panel that this was insufficient, and therefore these laboratories incurred a half a mark deduction. So characterization of the deletion should be performed. And if this is not possible, then further testing should be performed or advised to enable better interpretation of that variant. We also had laboratories that did not detect the deletion due to the limitations of the test method performed, and they were not given a critical error if these limitations were clearly stated on the report. So very similar to the germline case that Simon has just discussed. Some of the laboratories did not detect the deletion, but because of their test information and the scope of their test wasn't clear on the report, then this deletion we could not be determined whether or not it was within the scope of the test and should have been detected. Therefore, half a mark deduction was given. Next slide, please. So moving on to interpretation, this was a much better answered by all laboratories, and we only had 2 critical interpretation errors. One laboratory reported a long deletion with no further characterization, and this was considered a critical interpretation error due to this over-interpretation of a variant that really did not have any further information associated with it. The second laboratory advised PARP inhibitor therapy in relation to the presence of a variant of uncertain significance as a VUS, a class 3, and this was deemed a poor performing critical error. Some of the laboratories interpreted the variant in this case as being germline in origin due to the variant allelic frequency reported. And it's very clear here, and to just stress again, it's good practice to refer the patient to clinical genetics for germline testing, as the variant allelic frequencies may not always be accurate, as observed in this case, particularly when testing by next generation sequencing. So that really is a take-home message, I think, from this EQA run in itself. Next slide, please. So we move on to the second case. Again, this is a serious ovarian cancer lady who has had chemotherapy, which her tumour responded to, but now is being considered for maintenance PARP inhibitor treatment. So again, it's whether or not there is a pathogenic variant in BRCA1, BRCA2 in her tumour. So next slide, please. So the validated results here were that there was no pathogenic variants detected in either BRCA gene. And sadly, we saw another quite a high critical genotyping error rate with 10 laboratories, which is 3%, providing an incorrect genotype. So we had 5 false positive results. So these are BRCA1 and BRCA2 variants that had been reported where there was no pathogenic variant in the sample. And then we also saw a potential sample swap at some point in the participating laboratory who reported of the presence of a BRCA2 variant, which was actually supplied as case 3. Next slide, please. Interpretation was handled incredibly well by all laboratories here, and really the two messages were about the deductions were around not providing patient-specific interpretations, so very general interpretation not related to this particular patient and her clinical management of our own case, but generic information. So it's very strongly advised that you interpret the result within the context of your patient and not give multiple different interpretations based on if the result is X, then this is interpretation. If the result is Y, this is the alternative interpretation, which is very confusing for the reader of the report. And then I think the second big take-home message about is how important it is to make sure you have sufficient information on the report about the method used, the limitations of that method, and the scope of the testing, just to make sure that the reader of the report is aware of where the information may be limited and the interpretation cannot be extrapolated. And this is particularly important in samples, as in the case 1 was tested for large genomic rearrangements. So next case, please. Case 3 was a gentleman who had prostate cancer that had metastasized to his bones. So he's had a hormone treatment and testing's been requested to determine his eligibility for PARP inhibitor treatments. So it's the pathogenic variant present in his prostate tumor. Next slide, please. So the expected validated results for this case was that there was a BRCA2 pathogenic variant detected and nothing detected in BRCA1 to be reported. We had 14 critical genotyping errors reported for this case, which is approximately 4%. We had 8 false negative results, so this BRCA2 variant was not detected by the laboratories. We had 3 incorrect variants reported, so different variants in BRCA2. And then we had the same laboratory who didn't detect the BRCA2 variant, but we suspect there's a potential sample swap or a data swap within the laboratory, as this result would be matched to the case 2. So that's 3 of the laboratories had that issue. Next slide, please. So again, the interpretation was handled incredibly well, and the main reasons for small deductions across the scope of the EQA were very similar to those applied in case 1. So lack of awareness of a potential germline variant, so BRCA2 in this case could be within the gentleman's germline, overinterpretation of the variant allelic frequency, in other words, going even a further step, so being aware of it being potential germline, but over-interpreting it to conclude it is a germline variant, and also failure to recommend a referral for germline testing. So all very much around the same issue, but different elements where we can make sure that this is much better addressed going forward in other EQA schemes. So next slide, please. So this is the scoring summary. And as Simon discussed, that we often see the interpretation scores come up lower across the mean scoring than the genotyping. Case 1, you could see here we've got a lower genotyping score than the other cases, and that really was due to all the incorrect variants that were detected across the board. Interpretation for case 2 is particularly low across the 3 EQAs, and that's about the issue with not detailing the limitations of testing, particularly when no variants are detected. So next slide, please. And then finally, just to summarise the performance trends for the somatic EQA, you can see here that we are seeing a reduction in those laboratories that withdrew, but we still see a handful who do not submit results. And as Simon very clearly mentioned, this does result in poor performance. So we would encourage you to contact the EQA providers to give reasonings why you wish to withdraw or will not be submitting results. But the good news is we're about 90% of laboratories do submit results as expected. Across the top here, the graphs just show the overall mean scores year on year across genotyping and interpretation. And really you can see a drop in interpretation is quite predominant here in this 2022 EQA, and that's about the germline testing issue. We also see on the bottom graph here that we continue to have poor performing laboratories, and that has increased. It's not reducing like we're seeing in the germline scheme. And I think that really just reflects the nature of how somatic testing can be challenging, and the reinterpretation of the somatic test is also very challenging. But the good news is for this year, for the first year since this EQA has been run, we're not seeing laboratories with errors in all 3 cases. So I think we can say that things are improving dramatically. So I'm now going to hand back to Simon, and we're going to talk about the new pilot EQA that was delivered this year. Simon?
Thank you, Sandi. So let's move on to the next slide, please. So this scheme was a pilot scheme. So we always restrict access to our pilot schemes. They're there primarily to allow us to ensure that a new EQA scheme design is going to work in many different laboratories. So we're usually selective in terms of number of laboratories and selective in terms of what test technologies they're using, deliberately to try and challenge our hypotheses about the scheme design. So there were 50 laboratories registered for this scheme in 2022, and you can see again the breakdown reflects very similar to what we had in the germline and the somatic schemes. Just over 50% of laboratories from the EU, but surprisingly, this time there was a significant number of laboratories from the Asia Pacific region, excluding China, and China made up a much smaller percentage of the participants than it did in the other 2 schemes. So obviously a reflection, I think, of testing strategy, but don't read too much into it, because obviously this is a selection from the EMQN and GenQA teams in terms of participants. So it's not a true reflection of the participation in terms of global use of these types of tests. Next slide, please. So just to highlight, if you like, the challenges for the laboratories and the challenges for the EQA providers. Again, very similar to the somatic test, but somatic tumor testing, the tissue testing. But here, the predominant difficulty for laboratories is obtaining high quality cfDNA. And for us as EQA providers, that presents a real big challenge for us, is making sure we can provide cfDNA in a plasma matrix that's of the same standard to every laboratory. So clearly, again, like the somatic testing, it's not possible to use real tumor samples. And so we are, by definition, using artificial materials to ensure we've got homogeneity material substrates that we provide to every laboratory the same sample. But by doing that, we are now able to track parts of the process that have a big influence on the success rates of these assays. And we know that DNA extraction is a key failure part of the test process for cfDNA testing. So we're able to assess that as a proxy, if you like, by looking at the performance data from the laboratories. Also, understanding the limitations of cfDNA is important. So particularly in the context of BRCA genes and more widely in HRR testing, these are really complicated and difficult NGS-based tests. And most laboratories are using an NGS-based test. So in contrast to quite a few other cfDNA tests, for example, in lung cancer, where laboratories are using targeted tests or tests with very high sensitivity, like droplet digital PCR, in the context of a broader a broader gene scan from multiple different genes, where you don't have clearly defined variants in known locations in the gene, we are looking at genome scanning using NGS, and that's particularly in the context of these types of genes, difficult test contexts, and the variant allele frequency challenge also very difficult for NGS as well. So, and the other complexity to it is the use of strategies from laboratories that are designed for different sample types. So, for example, FFPE. So, quite a few laboratories are still using assays that are validated for use in FFPE, not for cfDNA. And really, laboratories do need to start thinking very hard about using assays that are specifically designed for cfDNA. Again, we've seen Sandi reported for the somatic variable experience in interpreting variants. So again, we want to provide laboratories with a range of different variant types and different classifications, so we can challenge the interpretation, the downstream interpretation of the findings, and include obviously the peer-reviewed expert review of the classification, and that feeds in nicely for some of the other EQA activities we're doing on BRCA gene classification that I'm sure you're all aware of. And finally, understanding the importance of potential germline variants. Again, it's the same scenario that we saw for the somatic tumor tissue. We've included this in our marking criteria, and obviously we're going to be discussing it again as part of this webinar, and it forms part of our sort of shared learning at the end of the webinar as well. So next slide, please. So for this pilot EQA, we used 3 artificial cfDNA samples manufactured in Germany by SensID. So uniform samples, 3 mils of plasma were sent out for each sample, containing a minimum of 80 nanograms per mil of cfDNA. We selected samples that included BRCA1 and 2 BRCA variants at a defined variant allele frequency. So we sent samples contained somewhere between 34 to 38% variant allele frequency, and the manufacturer validated that data using droplet digital PCR. And again, obviously, this is all in the background context of the licensing arrangements in Europe and more globally in terms of use of PARP inhibitor therapies and what genes should and shouldn't be tested. So validation, like all the other EQA schemes, we used two independently validated sample. Every sample was validated twice independently, using 2 tests for NGS, broader panel. And because this was a pilot EQA scheme, there were no poor performance issues for laboratories. So we weren't using performance monitoring. We were feeding back to laboratories on performance data, so whether they would have been a poor performer or not, but there were no consequences for being a poor performer in the pilot. Obviously, when we move this to a full EQA scheme next year, then poor performance criteria will be applied, and there will be performance issues associated with laboratories that are making critical errors. Next slide, please. So case 1 was a gentleman with metastatic castration-resistant prostate cancer. He'd been treated with hormone therapy and was now progressing. And because there was insufficient tissue available, cfDNA analysis has been requested to determine his eligibility for treatment with PARP inhibitor therapies. So here we're asking, is there a pathogenic variant present in his sample? Next slide, please. So the sample itself didn't contain any pathogenic variants in either BRCA1 or BRCA2. And the great take-home message here is no critical errors in either the genotyping or interpretation, which is good to see. As I said, this is a complex test, and we're delighted to see no errors were made. 17 laboratories, or 60% of laboratories, provided an interpretation which didn't take into account the amount of cfDNA present in the sample and the implications that may have for the negative test result. So in those cases, they were incorrectly suggesting there would be no response to PARP inhibitor therapy. 19 laboratories didn't suggest that repeat testing may be appropriate as a consequence, or that another cfDNA sample or alternatively a tumor tissue biopsy may be tested, and they received a deduction as a consequence. And 7 laboratories received deduction for not providing sufficient details regarding the limitations of the test provided. So Sandi again emphasised the importance of this, particularly in the context of tumour testing, whether it be solid tumours or plasma samples. You really need to make sure your report is very clear about the limitations of how you did that test. Next slide, please. So case 2 was a gentleman who again had castration-resistant prostate cancer, but this time it metastasized to his bones. He'd received chemotherapy and hormone therapy and was now progressing, was being considered for treatment with PARP inhibitor therapy. So it wasn't because it wasn't possible to take a sufficient tissue sample from him, cfDNA analysis was requested. So again, is there a pathogenic variant present in the sample? Next slide, please. So in this case, we were expecting laboratories to detect a variant in BRCA1, a pathogenic variant in BRCA1, at about 38% variant allele frequency and no pathogenic variant in BRCA2. The samples, as I alluded to earlier, were manufactured to very defined variant allele frequencies, plus and minus 5% on top of that. Each of those was measured by ddPCR. So we were very confident on what the true level of variant was present in this sample. So the interesting data comes from the validation laboratories. So we had significant deviation between the two in terms of what they were detecting for variant allele frequency. So one lab detected the variant at 2.4%, whilst the other detected it at 10%. But clearly, both of those were considerably lower than the expected 38% for this sample. And the mean allelic range variant allele frequency detected by the laboratories was between 1.02% and 49.55%. So you can see a huge variation there with a mean of 15%. 28 laboratories failed to submit a result for this case. And what made this sample so difficult was that the variant in the sample was present in an 8 base pair homopolymeric tract. And so this makes the sequencing and also the reading of the alignment of the sequence trees really difficult, and therefore makes it difficult to actually interpret the true amount of the variant present in the sample. So 15 laboratories, 54% of them reported the presence of the variant in this case, and 46% didn't report it. So about half and half reported it against those that didn't report it. And the variant, because of this alignment issue, is seen at lower variant allele frequencies in some samples. We know there's a known artifact that's causing problems in the sequencing process in this region because of that homopolymeric tract. So the generation of the true variant allele frequency using an NGS strategy is always going to be lower than the expected variant allele frequency, which in this case, as I said, was 38%. So because of this variability reporting the variant, we decided we wouldn't mark this case and we'd use it as an educational case. So laboratories, we fed back to all laboratories, but there were no deductions associated with the marking process. Next slide, please. So finally, case 3 was a gentleman, again, with castration-resistant prostate cancer that had metastasized to his bones. He'd received chemotherapy and hormone therapy and was now progressing and was being considered for the treatment with PARP inhibitor therapy. So in this case, it's a progression case. And is there a pathogenic variant present in his sample? Next slide, please. So the expected result, this time we were expecting laboratories to find a pathogenic variant at 34% in BRCA2 and no pathogenic variant in BRCA1. There were 3 or 10% critical genotyping errors, and all were false negatives, so the laboratories failed to detect the expected variant in BRCA2. This sample, again, all of the samples were the variant allele frequency the variants were manufactured to define frequency, and we measured using ddPCR. Again, we see the same sort of thing from the validation laboratories. One was picking up at 3.5%, and the other was picking up at 6%. And the mean reported variant allele frequency by the laboratories was 13.9%, with a range of 0.82 to 39.1%. So again, a big variation there in the ability of laboratories to detect the accurate variant allele frequency for these samples. Next slide, please. Looking at interpretation, there was one critical interpretation error. So in this case, the laboratory suggested that the patient may be at risk of other BRCA-related cancers. However, because it was a cfDNA sample that was tested, it's not possible to determine whether the variant is either somatic or germline in origin, and that laboratory received a critical interpretation error as a consequence. The variant could be germline in origin, and it was expected the laboratory would either refer the patient onto clinical genetics or request another sample for germline analysis. 3 laboratories didn't do this. A further 2 laboratories suggested that the variant was somatic in origin just based on the variant allele frequency, and they received a deduction because it was an assumption based on the variant allele frequency. And again, I guess kind of similar to case 2, for technical and biological reasons, you can't rely on variant allele frequency as a reliable indicator of whether any variant is either somatic or germline in nature. And we've emphasized that in this cfDNA scheme, but we've also picked up again on it in the somatic scheme, the variation you get in that data. Next slide, please. So looking at summary of scoring, so obviously we didn't mark case 2, and you can see case 1, which was the no pathogenic variants. The genotyping was really good, but we got significantly much poorer interpretation for the reasons we've already stated. Whereas in case 3, which did have a pathogenic variant in BRCA2, the genotyping, we saw quite a lot of errors in the genotyping and the interpretations to the scores, although better than case 1, particularly in interpretation, we're still substantially lower than an expected score of 2. Next slide, please. So looking at performance trends. So remember, we invited 50 laboratories to take part in the EQA scheme based on their testing strategy and their experience in undertaking cfDNA testing in prostate cancer. Half of the laboratories withdrew from the scheme for lots of different reasons, including technical reasons, availability of materials, use of sequences, etc., etc. So 50% of the participant laboratories submitted results, or just over 50% of them, and a very small number didn't return results. And the didn't return results is particularly pertinent in this case because we were very oversubscribed to take part in this pilot EQA scheme. So for every laboratory that doesn't submit results without at least giving us a reason, that's obviously depriving other laboratories that would like to take part from a place on the EQA scheme. So although there were no poor performance implications from this year's EQA scheme, again, we would encourage those laboratories to at least contact their EQA providers to let them understand why they're not able to submit results. We've already talked about the assessment scores, so I'm not going to go into that in any more detail, but you can see that the critical error rates were pretty low, actually. We were expecting to see considerably higher than 3%, probably in the region of 10% for this scheme because of the complexity of testing. So although we're looking at a small subset of laboratories, only 25, who have been selected on the basis of their experience, we still think that a critical error, genotyping error rate of 3% or just over is pretty good, and interpretation errors are about 1%. It'll be interesting to see how that evolves over time, as to whether when we open the scheme up more widely next year, whether we see a significant ramp up in the number of errors, number of critical errors made by laboratories. And obviously there are no poor performance criteria here, so there were no poor performing laboratories on the scheme as well. Okay, next slide, please. So I'll hand over to Sandi for the shared learning.
Thanks, Simon. So I think we can pull together some sort of like high-level observations across all of the 3 EQAs that we've just discussed today. So next slide, please. I'm very aware that we've sort of focused a bit on errors and some of the issues that have risen. And I think it's just as important to highlight some of the great work that is happening out there in the world of BRCA testing. I think there's a huge change and improvement with the compliance to HGVS variant nomenclature from many years ago when we started with these types of EQAs. So we're really seeing a high degree of compliance with the guidance out there, which is great to see, which really is important when we're using more and more databases and sharing information across different countries, as well as different testing strategies. We're also seeing an improvement in the use of reference sequences when describing where variants are positioned. And as Simon says, we're moving very actively over to the main initiative to make sure that we again have that standardization. And we're seeing a huge improvement in the reporting format as well. And we know it is challenging for laboratories, particularly when you need to integrate genomic test results into potentially cellular pathology reports or other reports to get that information concise and also displayed in such a way that it can't be misinterpreted easily. So we're seeing a lot more concise 1 to 2 page reports, fewer of them that are very, very long with complicated multi-pages. It really is quite difficult to pull out the expert areas that we need to target, such as the clear result and the clear patient-specific interpretation of that result. So we'll go to the next slide, but there's still work to do. And I think that's why we keep seeing an increase in participation across the years in these EQAs. Variant classification, I know we've just had a question in the Q&A box about guidelines for classification of variants in the somatic field. So many labs are still using ClinVar as just a single source of evidence, and we really want to promote the use that there are multiple resources out there, and really you should be looking across the system to see, gather as much evidence and information to classify your variants. There's ACMG and other suitable guidelines out there, including the AMPASCO and CAP somatic validation guidelines, Enigma, etc., that are focused more on the BRCA side of the variant classification. So we would recommend using all of the information that's available. Many labs are still reporting the presence of non-pathogenic variants, and really this is concerning just class 1 or class 2, the benign, likely benign classifications. We know that these can be misinterpreted. If you are scanning a report, and we know clinicians are incredibly busy, they don't have time to read every single text on the report that's issued, you can scan and you can be misinterpreting anything that is predicted to be benign and may interpret that as actually being a pathogenic variant and act upon it, which really would come to patient harm. We would be looking to see the clinical question being answered within the report. Many of the reports submitted still don't include a statement about the patient's likelihood of benefiting from PARP inhibitor therapy in the interpretation. We know this is dependent on country-specific practices, also local practices, and potentially how your system's set up, as in who does that interpretation. But it's very it's part of the clinical question, it's part of why the testing has been performed. So we would encourage that this is included in your report. When clinically relevant variants are not found in a germline sample, then it's really important to recommend further testing is performed to determine if there is a somatic variant present in the tumour. And this is some practice that we know, as I mentioned at the top of the call today, that some testing approaches are to test tumour first, and some is to check germline first. So we would really stress the importance of being aware of both potential variants being in germline and or somatic as well. So next slide, please. A few other areas where we can draw some conclusions across the schema as to refer to best practice. If you have a pathogenic variant detected in the tumour sample, it is quite likely that it could be germline in origin. So flip the other way from the previous point. So it's good practice to refer patients to clinical genetics or for genetic counselling for further investigation. And somewhere in the report, it's important to comment or indicate that there's a potential impact on the wider family of that patient that has been tested. We did see an increase of labs providing better details on methods, but we still saw that many are failing to provide sufficient detail on what is being tested, how it's being tested, and the limitations to that approach. And then we go into a lot of depth in the EQA scheme report, so I would point you in that direction. I think we saw quite a lot of the errors due to this particular fact in this year's EQA runs. So I think, again, it's about understanding exactly what you are doing and what you are not being able to test and report on with your approach taken. cfDNA testing, Simon's gone through some of the nuances and difficulties to performing this test, in particular for prostate cancer, but some of the assays that are being used, we can categorically say that they are not suitable for testing cell-free DNA plasma samples. A lot of methods, particularly DNA extraction methodologies that are being used, as well as the testing platforms, were not developed for plasma-based testing. They were developed for formalin-fixed paraffin-embedded FFPE samples. So we strongly recommend any laboratories using any of these methods or extraction processes to review your testing strategy and ensure that they are fully validated and fit for purpose for plasma-based testing. So next slide, please. So we're continuing to offer these 3 EQAs during 2023. We are sending the samples out. The distribution is planned for the autumn time. So all of them will be going out on the 18th of September. And then as normal, you get a period for testing and reporting. So the results submission deadline is the 17th of November. And then the assessment will take place, and the review and the publication of pre-appeals process with the final reports and finalised scores going out in April next year. So if anyone hasn't signed up and you are interested in, I think a lot of them are currently full at the moment, but we do have a reservation list if you'd wish to be added. So really do just contact both either EQA providers and we'll see if we can help out. So next slide. Thank you very much indeed. We have a couple of questions that have been submitted, but I would encourage you to submit anything else that you'd like answered today. I see we're at the top of the hour, but I think, Simon, we could maybe squeeze a couple of questions in.
Yeah, I think we can squeeze two or three questions in, Sandy. So I've got a question here about, well, first of all, well done for a great presentation. That's what the comment says, which is fantastic. Thank you. Are there any plans to offer the schemes in other languages than English?
So I think that's something that we are considering. It is something that both EQA providers do for other schemes. The GenQA molecular pathology schemes this year are open in multiple language submissions. And I think it's something that Simon and I can discuss going forward for these particular EQAs, if it's something that would be helpful to the participants. So Simon, would you agree with that? We're very open to improving the services that we supply. Absolutely,
and I think this may be something that laboratories could record in the feedback as to what they would like to see as in terms of improvements. But yes, certainly. Yeah. I think it's fairly standard practice for most of our EQA schemes, but across both providers, to do multiple languages. And we would, if we can facilitate it, and the complexity obviously here is being able to read the nuances of interpretation written in a different language. That's the difficulty, and that's why it's so challenging. But if we can do that, then I'm sure we can facilitate that, and we will certainly look into that for future years. Yes.
Great, thank you. One of the other questions that I alluded to as well when we were talking about variants is we've been asked a question, interested to know if the laboratories used AMP guidelines to assess the classification of the somatic samples. So I think what we can say from the EQA run is that we do not ask that specific question. So unless it's stated on the reports, we're not able to deduce that. But what we do provide is variant classification external quality assessment schemes, whereby we do include that information, and we have a lot of webinars and guidance. And then currently, I think we're just completing run 10 of the BRCA and HRR gene variant interpretation schemes, but we also have particular somatic variant interpretation and classification schemes as well. So I would say that we can't cover everything in these particular ones. So we do separate them out, particular elements of that testing process at end to end. So please get in touch with us if that's something that you're interested in. But I do know that we've just assessed the latest run of the somatic variant scheme, and there is huge variation of the different guidelines that people are using. So until I think it gets easier to assess, it's quite difficult to include that into any of the scoring of these EQAs.
Sandi, I think we've got time for two more questions.
Yeah.
So I've got one here, which is, are we considering including any other HRD genes? So just to give an overview of the rationale for why we've been focusing on BRCA1 and BRCA2, particularly in the somatic and the cfDNA scheme. It's primarily driven by licensing. But certainly in the germline scheme in the past, and we didn't include it this year, but we have included other HRR genes, so a broader test context, and we will continue to do that, and we will obviously amend the scheme design and the variants we provide based on the licensing requirements. So at the moment, the licensing only covers BRCA1 and BRCA2, so that's why it's restricted for the time being, but we will obviously keep that in mind for future EQA schemes.
Yeah, and also maybe just to signpost that we have our NGS, joint NGS technical EQA, that you can submit variant call files and data for any size of panel up to whole genome sequencing. So if you want EQAs on those particular areas and that is in the scope of your panel, then you can have that through a different route by the NGS technical EQA, if that's of help.
Yeah, in fact, actually that's true. We probably ought to highlight that we do that for both germline and somatic testing, yes, including laboratories that are using matched normal samples. And that would be an applicable route if you wanted to get assessment of other variants that are not currently included in the clinical context.
Yeah.
One more question, Sandi, I think, time for?
Yep, there's one here. Read your recommendation to offer germline testing for actionable variants BRCA1, BRCA2 when detected in cfDNA specimens. Has there been any discussion on the VAF cutoffs where they should be offered, or is it all variants? Do you want to take that one, Simon, or will I?
Why don't you take that one, Sandi?
Okay.
The last one of the day.
That's fine. It's a really good question, and it's very controversial, and it depends who you speak to. So I know that many laboratories are very proud to be able to detect variants in liquid biopsy samples to very, very low frequencies. However, I'm also aware that a lot of clinical teams will not act upon that information until they actually see progression, disease progression on radiology or, in their patients, because they wish them to be retained on the current treatment for as long as possible before they switch to other treatments. So I think it's very much a local decision. It's a decision that you need to discuss with your service users, whether or not they want that information. Because the flip side is also, if the laboratories do report low variant allelic frequencies, does the clinician then have a responsibility to act upon that, whereby if it was held within the laboratory until they actually agreed of when that frequency would tip over action, that they would, the clinic teams would be much more comfortable. So I'm not going to give you a straight answer, I'm afraid, because it depends who you speak to. So I would definitely have that conversation locally to set up what practice that your service users would like you to do.
Okay. I think we'll call it a day. At the end of the day, we've got a few other questions which we've got your name, so we can obviously feed back to you directly afterwards, and we will make sure we do that for you. So without further ado, I just want to say thank you to you, the participants. Again, we're glad we're providing these webinars to you, the masterclasses. We hope you found it productive. Please do make sure you feed back to us by the survey. So a big thank you to you. A big thank you to my co-chair Sandi, and also to the sponsors, AstraZeneca and Merck Sharp and Dohme, because obviously they've contributed to supporting these EQAs. And we'll look forward to you joining us in our 2023 schemes and our 2023 webinar sometime in May in 2024. So have a good afternoon, and thank you once again for joining in. Take care. Bye.
Thank you. Bye-bye.